All right, so let's go ahead and solve this example problem here. What we want to do here is we want to determine, this is example problem 11.10 from the textbook. It says we want to determine the power factor and the average power delivered by the source. Okay, so determine power factor, average power delivered by the source. Okay? So that's what we're trying to set out to do here. I do want to note that it's interesting the way that they write this voltage source. They say it's 30 angle 0 volts RMS, but an RMS value is a DC value. So why in the world would they write it that way? Well, my understanding is what they're saying is that this signal is swinging with an angle of 0 and a peak value of VP, and the RMS value of that signal is 30 volts. Okay, RMS. So that's my understanding of what they're saying about this source. So let me just go ahead and grab that and we'll minimize it and just throw it up there so that we can make sure we understand what's going on here. Okay, and so what we can do here is, of course, we know that if we want to characterize the circuit, we need to figure out the current I, RMS, that's leaving the source. And so the best way to do that would be to find an equivalent for this impedance that we have here, which is, a capacitor with two resistors. And so we can replace the resistors and the capacitor with equivalent impedances, just like this. And then this entire thing can be replaced with just a single impedance, ZEQ, which is what we're after, right? Because if we can determine ZEQ, then we know IRMS, right? My equivalent circuit at that point would basically be, here's my voltage source, and IRMS would just be the voltage RMS across my equivalent impedance, right? So that's what we're going for. And so let's go ahead and do that. Well, first we notice that the capacitor and the 4 ohm resistor, right? They are in parallel. So I can say ZEQ1, which is going to be just these two. That's going to be equal to the product. So minus J2 times 4 over the sum, 4 minus J2. That's going to be minus J8 over 4 minus J2. I'll go ahead and throw that in my calculator. Of course, you could convert it into a phasor, but I'm not going to do that. Divide by 4 minus 2i, and I get 0.8 minus J1.6. Okay? And so now I just have to add 6 to that, right? Because there's a 6 ohm resistor in series with that. So I basically went from my original to this. I have 6 ohms, and I have ZEQ1 right here that I just found. And then I'm going to add 6 to this so that I can get my ZEQ final, which is just going to be, right? ZEQ final is going to be 6 ohms plus 0.8 minus J1.6 ohms. I add 6 to my 0.8, and I'm basically going to end up with ZEQ final is going to be 6.8 minus J1.6 ohms, right? And that's going to go right here. Okay, so now all I have to do is connect. Let me just delete this. All I have to do is connect my source here, my 30 volts RMS source, and I can find the RMS current, and I'll have everything I need to find the average power, right? And so if I go ahead and do that, I can say maybe I do want to convert my ZEQ into a phasor here, minus 1.6i. Okay, and I can say math complex And so my polar form here, my phasor form here is going to be 6.986, it looks like. Angle negative 13.24 degrees. And this is ohms. And so if I'm looking for I RMS, it's going to be V over Z, which is going to be 30 angle 0 volts RMS divided by 6.986 angle negative 13.24 degrees ohms. And that's going to come out to I RMS equals, of course, I can divide my magnitude. So 30 divided by 6.986 is going to give me 4.294. And then my angle is just going to be 0 minus negative 13.27 or 13.27 degrees amps RMS, okay? So I've got my current RMS. Of course, I've got my voltage RMS, which was given. And so now in the next video, I'm just going to go ahead and end this video here. In the next video, I will use the RMS current and the RMS voltage that I found, and I'll go ahead and calculate my power factor and my average power delivered by the source as the problem asks. Okay, so I'm going to go ahead and end this video right here.